Okay, the last tests I want to talk about, the last algebraic tests anyway, until we get to integration, are going to be the root test and the ratio test. And these are two more tests to see if a series converges or not. And they're fairly similar in how they're used. So let's first write down the root test. Okay, so let S sub n be a sequence. Then sort of three things happen. The sum of S sub n converges if the lim sup of the nth roots of the absolute value of S sub n is less than 1. Okay, it diverges if that same thing, the lim sup of the nth root of the absolute value of S sub n as n goes to infinity is bigger than 1, and it doesn't say anything at all. There's no information gained or about convergence or divergence if it's equal to 1. So there's no information about convergence if the lim sup as n goes to infinity of the nth root of the absolute value of S sub n is equal to 1. Okay, so we're going to use the comparison test after we sort of manipulate this lim sup thing a little bit. So proof, say let alpha equal the lim sup of the nth root of the absolute value of S sub n. Okay. If alpha is less than 1, then set beta equal to 1 plus alpha over 2, which is also less than 1. So alpha less than beta strictly less than 1. So beta is somewhere in the middle, halfway between alpha and 1. Then, since alpha was the lim sup, there exists n with the nth root of S sub n strictly less than beta for all n bigger than n. Because alpha was the lim sup, and I've gone a little bit bigger than alpha, that means eventually that sequence has to always be smaller than beta. I can give you a reference. This would be referenced as Theorem 3.17b if you like. Okay. So I'll just do a little bit of algebraic manipulation. Raised to the nth power on both sides. I get the absolute value of S sub n is less than beta to the n is less than 1. i.e., take c sub n equal to beta to the n in the comparison test. Then the sum of S sub n converges. Okay, So I figured out the thing that I should compare it to by looking at the lim sup. I compare it, and the comparison test says it converges. Okay. Conversely, if alpha is bigger than 1, set beta equal to the same thing, 1 plus alpha over 2, which would be bigger than 1, sort of. So alpha is bigger than beta is bigger than 1. Then use the comparison test again. With divergence this time instead. Okay. And if it's equal to 1, I can't actually do that, because when we're equal to 1, I can't sort of find this beta that works right. So I don't get any information at all. Okay. That's the root test. The ratio test is fairly similar. And the ratio test says the sum of a sub n, sort of two things again. One, converges if the lim sup of the ratios a sub n plus 1 over a sub n is less than 1. Diverges if lim sup of the ratio a sub n plus 1 over a sub n is bigger than 1, and no information about convergence if lim sup of the ratio equals 1. And it's pretty much exactly the same proof. I'll let you read that and look through it if you want to. Okay. So a little bit about the root test and the ratio test. Root test and ratio test. These are used quite a bit when we start talking about series. And they're used to find the radius of convergence of a series. We'll get to that, but whenever the root test works, the ratio test also kind of works. The root test is a stronger test. Whenever the how do I want to say this? Let's look at this little theorem. So the lim nth of c sub n plus 1 over c sub n is less than or equal to the lim nth of the nth root of c sub n. And the lim sup of the nth root of c sub n is smaller than or equal to the lim sup of c sub n plus 1 over c sub n. C sub n's positive. C sub n's okay in both of these. So what that says is, if this thing is less than 1, then this thing is less than 1 too. So the root test is a little bit of a stronger test. If this is bigger than 1, then so is this. So the root test works in more cases than the ratio test. This theorem states the root test works more often than the ratio test. But the problem is the root test is a little bit harder to use. Showing convergence about the nth root of something, the nth root of something is usually a lot harder to work with than just division. Okay, so, but it's harder to use in many situations.